General relativity, step by step. I've been looking for a candidate X for the left-hand side for the field equations. This being the stress-energy tensor, stress-energy momentum tensor, and this is something as yet undetermined. And the first attempt I had was to use the Ricci tensor, but this was a fail. This was a fail. This was a fail because the divergence of it was not equal to 0, and the divergence of the right-hand side should be equal to 0 because we know, that this equation holds identically. Well, okay, so it failed, but we did learn quite a lot about how the Ricci tensor operates, and it almost worked. There were quite a lot of cancellations out here, but it wasn't quite perfect. So what I'm going to try and do is to rescue the field equations by adding other terms, which I'll find from somewhere, and demanding that the covariant derivative, the covariant divergence is equal to 0. I'm going to demand this. I'm going to demand that that holds. So I'm going to find restrictions on my other terms there. So what have I got? I've got R alpha beta plus, I can't add, let's say, the mu nu. That won't do because I need 2 upstairs indices and I've got 1 up and 3 down here. So whatever I add to it, I've got to add things with 2 or tensors with 2 upstairs indices. So what have I got at my disposal? Well, I've got the fundamental tensor, I've got the metric tensor, and of course if I've got the metric tensor I can just add any scalar I like to it. There we go. And I'll just have a think about that. And we've also got the Ricci tensor here, R. That's the Ricci curvature tensor. Curvature scalar. Okay, so I've got the curvature scalar, and again, this is not a consistent equation because I've got 2 upstairs indices here, and this is a scalar. It's a function of position and time, to be sure, but it is fundamentally a scalar, so I need to multiply it by, well, what can I multiply it by? That's questionable. I can in theory multiply it by the Ricci tensor, but it's non-linear. And as soon as you get non-linearity, then everything gets horribly, horribly complicated. Which isn't a reason for it to be wrong, it's just a reason to try everything else first. We'll try everything that we can think of that gives us a linear set of equations first, and then we'll start fooling around with non-linearity. So I'm just going to bin that without even thinking about it. Even so, as that equation stands, it's unacceptable because we've got a scalar plus a second order tensor. So I'm going to multiply it by the metric tensor. And I'm going to call it B, which is some constant. So that's constant, and what's this thing? That's the metric tensor. Metric tensor. And what I'm going to do is I'm going to demand that R alpha beta plus this funny thing gamma here, which I'll talk about in some detail later on, B times the Ricci curvature scalar times G alpha beta, covariant derivative, I'm going to demand that that equals 0. So at the moment I don't know what that is and I don't know what that is, but if I can find a pair of numbers lambda and B such that this holds, this will be a candidate for the field equations and it might work. So that's what I'm going to do, and I'm going to stop there and do it in the next screencast. Stop.